So we started sequences last week in class on Thursday. Today we're going to focus on a special type of sequence called an arithmetic sequence. Generally we'll represent any sort of sequence with a sub 1, a sub 2, a sub 3, so on. Some little subscripts, which are counting the terms in the sequence. An easy type of problem would be to say, find the first 5 terms of a sub n equals, and then you're given some formula. And so the way I would do that is I'd start by saying, well, n equals 1, so a sub 1 equals 3 times 1 plus 7, which is 10. And then a sub 2 equals 3 times 2 plus 7, so 13. A sub 3, and so on. And so maybe I see the pattern at that point: 10, 13, 16, 19, 22. Similarly, let's say I want to find the first 5 terms of, say, a sub n equals like n times n minus 1. So a sub 1 would be 1 times 0, which is 0. A sub 2 would be 2 times 1, so 2. A sub 3, 3 times 2 is 6. A sub 4, 4 times 3 equals 12. And a sub 5 equals 5 times 4 equals 20. And so I'm just replacing the n in the formula with the subscript for the first, second, third, fourth, and fifth term. And so I end up with this pattern: 0, 2, 6, 12, 20. Okay, so that's sequences in general. An arithmetic sequence there's a constant difference between terms. So for example, looking at these 2 problems, the first example was plus 3, plus 3, plus 3 as I go from term to term. That's a constant difference. So this is an example of an arithmetic sequence. In the second example, 0, 2, 6, 12, 20, it's plus 2, plus 4, plus 6, plus 8. There's a pattern in the differences, but it's not constant. So that is not arithmetic. The formula for an arithmetic sequence is always going to be that the nth term equals a sub 1, which is the first term, plus the constant difference times n minus 1. So that's sort of an important formula for us. So if I say, find a formula for say 1, 6, 11, 16, 21, so on. The first thing I'm going to see is that it's plus 5, plus 5, plus 5. So that's the constant difference, and that's the d. I should have said that up here, sorry. So here, to find the formula, I'm going to write a sub n equals the first term, so 1, plus the constant difference, 5, times n minus 1. And I can leave my answer like that. If I want to simplify it to 5n minus 4, I can do that too. But either one of those is fine. A second, pretty straightforward example. Find a formula for 100, 93, 86, 79, ... In this instance, what I'll see is 93 minus 100 is negative 7. And then 83 minus 97 is negative 7, negative 7. So the difference can be positive, which means the sequence is increasing. The difference can be negative, which means the sequence is decreasing. So here I'd say a sub n equals 100, first term, plus negative 7, constant difference, times n minus 1. And I can simplify that again, not necessary, to negative 7n plus 107. The most challenging type of problem of this sort that I can think of is, let's say I tell you that I've got some sequence, find a formula for, where the 10th term is given and maybe like the 20th term is given, but you're not given any other information than that. And here's the trick, is that the constant difference, I can always find it by finding the difference between the terms in the sequence and dividing by the number of the terms. And so 64 minus 24, so there's some sequence where there's like a 24 and then there's a sub 11, a sub 12, a sub 13, dot, 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 a sub 19, and then 64. And so I don't know what those are. So I'm subtracting 64 minus 24 to get 40. And then the 20 minus 10 is saying that there were 10 D's that were added in between the 24 and the 64. And so 1D equals 4. To write the equation of the sequence, though, I still need the first term. And so I can find that by just plugging in either one of these. And so I'll say 24 equals a sub 1, which I don't know, plus 4, which we just discovered, times 10 minus 1, because I'm now using a sub 10 equals 24. And so I can simplify that. 24 equals a sub 1 plus 36. And so negative 12 equals a sub 1. And so putting all of that together, I get that the nth term is negative 12 plus 4 times n minus 1. The homework for tonight is just some practice writing equations and using arithmetic sequences.